Good morning. So I recorded this video to talk about empirical distribution, and I am looking at the slides from 3.2. By the end of it, you may find them in our Blackboard course site. So what we're going to talk about significantly high and significantly low values, but I also want to talk about empirical distribution. So empirical rule, it's about measures of position, and we can implement this rule if we do have a bell-shaped symmetric distribution. So again, empirical rule is something that we can implement for measures of position if we do have bell-shaped symmetric distribution. Okay, this is my cat. He's getting into the picture. All right. So what does this rule says? It says, I'm going to draw it, but I just want to explain it on the slides also. So we do have a distribution mean, which cuts the distribution in the middle. And if we go one standard deviation up and one standard deviation down, we will be in the 68% of the crowd. Then if we go 2 standard deviations up and 2 standard deviations down from the mean, then we will be in the 95%, we will be covering 95% of the population. And if we go 2 standard deviations up from the center, from the mean, 2 standard deviations down, then we will be covering 99.7% of the distribution. So significantly high means that any data values higher than 2 standard deviation, that will be significantly high. Any data values that are lower than 2 standard deviation, that will be significantly low. All right, as a summary, if we want to use empirical distribution as a measure of position, we must be able to see a bell-shaped symmetric distribution. 1. In that distribution, we call the rule based on percentages 68, 95, and 99.7. So 68% goes 1 standard deviation up, 1 standard deviation down of the population. So that is plus or minus 1 standard deviation. 95% means we're going up and down for 2 standard deviations. 99.7% means we're going up and down 3 standard deviations. So this is the theory. Now, how this theory is going to be related to the problems that we're going to see. So I'm going to look at this IQ problem given in the slides, then we're going to see one example of it. Okay, so IQ scores, as they're saying here, is a bell-shaped distribution. So that gives us a check mark that we can implement empirical distribution with a mean of 100. So sample mean, we can show sample mean with X bar 100 and a standard deviation of 15. Sample standard deviation, that's the symbol, with 15. Okay, so first let's draw this distribution. What is it going to look like? Let's have a look into that. All right, so this is a bell-shaped distribution. In this bell-shaped distribution, we do have a sample mean, X bar, 100. And if we go up 1 standard deviation, that will be 115 IQ scores. If we go down 1 standard deviation, because standard deviation hence was 15, 100 minus 15, that will be 85. So it means that 68% of the people have IQ scores between 85 to 115. So now we put it in context. Now I want to talk about something else. Because this red corridor is 68%, and because mean cuts the distribution into two halves, we can comfortably say that this portion will be 34%, and this portion will be 34% also. So what that means, 34% of the people has an IQ score between 85 and 100. 34% of people has an IQ score between 100 and 150. So I want you to look at this picture carefully. It's 34. I'm not taking this picture's detailed 34.14 or 13.59. All right, so this is a kind of an easier and more convenient way dealing with the percentages, so we can go with that. Okay, so let's keep that in mind. So going back to 68, 95, and 99.7 rule. Now, if we go one more standard deviation up, okay, I want to change my pen. All right. And one more standard deviation down. So hence, each of them are one standard deviation. Okay. Let's see if I can. Yep. Each of them are one standard deviation. All right. So if we go one more standard deviation up and one more standard deviation down, so we will be covering 95%. And what are the values on the horizontal axis? So 100 minus 30, so that will be 70. 100 plus 30 is 130. So it means that 95% of the people have IQ scores ranging from 70 to 130. So hence, this second standard deviation is our fence, okay, for usual range. That constitutes the usual range. 2 standard deviation below, 2 standard deviation above. If somebody has an IQ score 69, that will be unusually low. If somebody has an IQ score 135, that will be unusually high. Right, so let's do the 3 standard deviation. So we're gonna add 45 and subtract 45. And then that will be 145 here and 55 there. So then we almost covering everyone's IQ score, which is 99.7%, and it is going from 55 to 145. So one more thing we forgot to do, same as like 34 on the 68. So again, mean divides this distribution half. Okay. So my notebook has its own mind. Yeah, clearly it does. Okay, let's try it again. One more time. No. All right. Let's change the pen. Let's try again. All right, let's see. That works. Okay, so we did have 34. Now, if you want to do this half with the 95%, how is that going to work? So because we're covering 95% from 70 to 130, this lot will be 47.5, and this little slide will be 47.5 minus 34, 13.5%. So we can say that 13.5% of people have IQs changing from 115 to 130, and same here. This will be 13.5%. 0.5%. Oop! Mr. Pink? No. All right. Okay. I'm being challenged by my cat here. Come. Okay, one more. So Control C, Control C, Control C, Control C. Yep. So 13.5% here. All right. So if we do the same thing for 99.7, right? So we're going 99.7 from 55 to 145. If you divide 99.7 with 2, so here's the algebra. So 0.997 divide by 2, you will get 49.85. So that 49.85 is going from 100 to 145, right? So if we subtract 47.5, just to find this little portion, how much it is, and that will give us 0.0235, and this is this small slice here. 0.2035, and that will be the same slice here. 0.0235. Okay, and then what also matters for us, the little tails. So how much is left? And the way we're going to do that, we're going to accept that the whole thing is 1. So 1 minus 0.997, that will be 0.003. And because it's symmetric, the portion here and here should be the same. And if we divide 0.003 by 2, we will get 0.0015. So this will be 0.0015 and 0.0015. So one more thing, students oftentimes confused with that. That is as a decimal, 0.0015. If you want to write it as a percentage, right? So that will be 0.15%. Okay, so this was about empirical distribution intro done with this example. And how are we going to answer these questions? For instance, what percentage of IQ scores are between 70 and 130? 70 and 130, 95%. So that's the 2 standard deviation one, right? So this will be 95%. What percentage of IQ scores are between 70 and 100? We're going 70 from 100. It is this area, and this area is 37.5%, right? 47.5%, sorry. What percentage of IQ scores are higher than 145? Higher than 145 is here. That's 0.15%. Or if you want to write it in decimal, 0.015. What percentage of IQ scores are lower than 115? Lower than 150. Oh, this is a whole lot area. This is this area, right? So it could be done in multiple ways. While you know how much is left here, you can subtract it from 1, this portion, or you can add each of these slices. Like, for instance, we have 68% here, right? And then we have 13.5. And then we have 0.0235 and 0.0015. That's kind of long. Maybe it's better to add this portion and subtract it from 1. So let's do that. Okay, so we have 13 and a half